All right, so moving on to question E. This time we're going to take the 2 and multiply them. And again, you have a couple of options. I've been showing you one option kind of consistently, so now I'm going to show you the other. And this other idea is, since you have already multiplied f of x times g of x in part C, and in E, they just want you to put 16 in for the whole thing, you can actually just take your final product of 192x to the 4th and put 16 in. So 192 with 16 to the 4th power. So when you do that, you actually get a pretty big number. You get this. Okay? And then you can do the same idea for f. Since you already divided up here in D, and you ended up getting 3, the idea again is that you can just take your final result of D and put 16 in. Now what ended up happening on D is the x squareds actually canceled out, if you recall here, and we were left with 3. So that's what you'll end up with on F, is the answer of 3. If you do this the long way and you just put 16 in for these right here, 24 times 16 squared over 8 times 16 squared. Again, just remember, anything dividing by itself is 1, or they would cancel out, so you'd still get 24 divided by 8 and get the 3. All right, on 15, we have another composition function, and this says over here that we're going to take g and put it into f. So this is going to go in for that x. So again, when you put it in there, put it in parentheses. So you have the 7, and in for x, in parentheses goes x squared, and then the 5th power. Before I simplify this, I will look at the domain issue, and I want to check to see if I have x in a denominator, which I don't, or x in an even radical, which I don't either. So the domain is whatever you want, so you can put your infinities. And now I'm going to simplify this, and this goes back to chapter 5a before break, winter break, and that you will just multiply those exponents, and when you do, the 7 comes along and you get x to the 10th. That is a 10th power. All right, 16 and 17. So what we're doing here is we are finding the inverses. So again, it doesn't ask anything about domain here, so we'll just be finding the inverses. So first of all, you want to look at this h of x as a y, or this q of x as a y. And our first step is to take the x and the y in the problem and switch them around. So I'm going to make this be x equal 1/2. And I'm going to switch, that x to a y. So in my class, I talked about, if you have your graphing calculator, there's a couple ways that you can see if you did this right. One is you can graph your original function and then the inverse, and then put those into y1, y2, and also put the equation y equals x, and see if you get a reflection over the line y equals x. Probably a simpler way to do this is go ahead and graph your first original equation, the y equals 1/2 x plus 3 cubed minus 4. And I know I don't have a calculator that you guys can see right now, but I have one in front of me, and I'm just looking on my calculator and checking out a point that would work. And so one point that I noticed that works is -1, 0. And what happens then is when I find the inverse, the point for the inverse should just switch that around. I should have 0, -1. So that's what I'm going to check out, is to see if that happens. So I'm going to work on getting this new y in my equation by itself. So the first thing I'm going to do is add this 4 over on the right. And on the left side, we're now at x plus 4. And we have 1/2 with all of this. The next thing I'm going to get rid of is the 1/2. I'm going to multiply by the reciprocal. I'm going to multiply it by 2. And that cancels that out. And then I'm going to multiply all of this by 2. So I'm just going to write it like that. And you can distribute the 2 if you want, but you don't need to. It's up to you. So let's say you don't, and you have this on the left side. And on the right side, you still have this y plus 3 cubed. The next thing I'm going to move is the cube, and I'm going to do that by cube rooting the right side, which means I'm going to cube root the entire left side. And at this point, we have, I'm kind of running out of room here, we're going to have, put it right here, the cubed root. And again, you could distribute that too if you want. And on the right side, we have y plus 3. And now to get y by itself, I'm going to subtract 3. So when I'm done, in this box right here will be the final answer. I'm going to have the cubed root of 2 parentheses x plus 4. I'm going to close those parentheses, and then I will be subtracting 3. And that subtracting 3 is on the outside. You can have it equal y. Maybe your teacher wants you to write it with that inverse notation. Well, it's not an F, was it? It was an H. So I will be erasing this in a little bit so I can use the boxes for the other one. I should have had some more space. So now what I'm going to do is type this into my graphing calculator and see if the point 0, -1 does pop up. So I just typed it into my calculator, and 0, -1 does show up as a point for this new one. Okay, so take a moment, get that written down, because I'm going to be doing some erasing, so I have some room for 17. All right, I'll try to write a little neater here. So again, what I'm going to do is find the inverse. So I'm going to switch the x and y around. And now my goal is to get this y by itself. And so the first thing I'm going to be moving is the 2. I'm going to be dividing by 2. And I'm going to divide by 2 over here. So at this point, you could write it, if you want, as a half x. And then you have the cubed root of y minus 5. I'm sorry, square root. And now I'm going to get rid of the square root. I'm going to square both sides. So I'm going to square this side, and that cancels out the square root. So you're just left with y minus 5. And then I'm going to square this whole side, so that on this side I have, I'm going to go ahead and square 1/2 and x. That'll be 1/4 and x squared. And now my last step to get y by itself is just to add 5. So if you're going to write it with the inverse notation, you have that, and it's going to be 1/4 x squared plus 5. And again, if you want to check to see if a point works, put this in your calculator. You will have to pick a point that works within the domain. So you have to pick something that's greater than or equal to 5. So make sure that your point is 5 something, 6 something, so that when you check, it's going to work over here. Okay? All right, moving on to 18. We're going to find the inverse. Again, switch this to y, and then switch x and y around. And now our job is to get the y by itself. So first thing I'm going to move is the 7. They divided by 7, so I'm going to multiply by 7. Let's move this over a little more. On the left side, we've got 7x. On the right side, we've got 4y. And now to get y by itself, I'm just going to divide by 4. So when you're done, you have 7/4 x equals y, or you could write it as its inverse notation. And 19, same thing, change g of x into y, and then you can switch x and y around. And now I'm going to work on getting that y by itself. The first thing I'm going to move is the -4. I'm going to add 4. So on the left, we've got x plus 4. On the right, we have 2y to the 5th. The next thing I'm going to move is the 2, divide by 2. I'm going to go ahead and come over here and just divide each part by 2. So where we are right now is a half x plus 2 and equals y to the 5th. And then the last thing is to get rid of the 5th power, we're going to 5th root. So I'm going to 5th root this, and then I'm going to 5th root this whole thing here. So when you're done, your inverse, if you want to write it like that, is the 5th root, and inside that 5th root is 1/2 x plus 2. All right, the final section is proving using composition functions that these two functions are inverses of each other. And when this happens, I'm going to need some more room, so I will probably be going down into this section here, is I will have to take g of f of x, And then I will also have to take f of g of x. And if this works, when I'm done simplifying, I should get x on both of these. So we're going to start with taking f and putting it into g. So all of this is going to go in here. So I'll still have the 1/2. I'm going to switch colors just so you can see. N for x is going to go f of x. So here you go. You can kind of see the difference. And then I still have the +3. And my job is to simplify this now to see if I can get just to x. So the first thing I'm going to do is just distribute this 1/2. So half of 2x is x. Half of 6 is 3. And then I still have the +3 that's there. And when I'm done, these 3's will cancel out, so I get to just x. So now what I'm going to do is the opposite. Now I'm going to take g and put it into f. So g is going to go into f. So this time up here, this will go in here. So the 2 is there. Let's separate this out. N for x will go 1/2 x plus 3. And then I still have the -6. And now to simplify it, I'll distribute the 2. And I'm going to get x, because 2 times half x is 2. I'll get 6 from 2 and 3. And then there's still the -6. And then these 6's will cancel out, so you just get to x. So are these inverses of each other? Yes, they are, because we get x. And again, that x is that line of the reflection. If you had graphed this in your graphing calculator and g of x in your graphing calculator and the line y equals x in your calculator, you would have seen that f of x and g of x reflect over this line. So let's check out 21. So on 21, again, what I'm going to have to do is take g of f of x and try to get x, and f of g of x and try to get x. So 20 looks, I think, just overall a little bit easier than 21. So when we do 21, we're going to really start to notice or pay attention to how things cancel out or disappear to get to x. So let's start with this one. Here we're going to take f and put it into g. I'm going to erase this from the other one. So this is going to go in here. So I'm going to start with g of x. And the x is going to be replaced with the 2x squared plus 1. I still have the -1. And then everything's over 2. So how do I start to get to just x? So the first thing I want to note is I'm going to be getting rid of the 1's first. Okay, so just a little side note here, what I got rid of first. So here I got rid of the 1's first. So from there, I'm left with the square root of 2x squared over 2. The next thing I'm going to be getting rid of is the regular size 2's. So I'm just going to put regular 2's. So then what I'm left with is just the square root of x squared, and then the square root and the squared, so the little 2's, will cancel out and I get to just x. So I'm going to do the same thing. I'm going to take g over here and put it into f. So this time all of this is going to go right there. So 2, and then I'm going to start my parentheses, and in the parentheses will go the big square root, x minus 1 over 2, and then that is all supposed to be squared, and then I still have the plus 1. So what should happen here is, since the little 2's, the square and the square root went away last, here they're going to go away first. So this squared will take out the little square root that's there, so that you're still left with x minus 1 over 2, but it's not in the square root anymore. So the next thing I'm going to get rid of are the regular 2's. This 2 would distribute in to this fraction, and they would cancel out. So you're left with x minus 1 plus 1, and then the last thing that will go away are the 1's. And so when those are canceled out, you're just left with x. So yes, these are inverses of each other. And that's it. That's the review.